Okay, hi guys. So in this lecture, we'll be seeing mechanism of as to how the HIO4, which is a oxidizing agent, which we discussed in the previous lecture, does its oxidation part. So we'll be taking on that. So let's look at the mechanism of HIO4. So we have vicinal diol on reacting with HIO4. This is the structure of HIO4. Okay. For now, how this structure of HIO4 is derived is not in the scope of this lectures. We'll see the structure parts and all those things in our set of inorganic chemistry lectures. Okay, so what will happen is we'll have dehydration from the H2 of the vicinal diol and oxygen of the HIO4 minus or HIO4. Okay, and as a result it will form something like this compound. Okay, and next what will happen is the bond rearrangements will take place, in which this bond will be taken by the iodine atom, and this bond electrons will be taken by the oxygen atom, and this bond electrons will be taken by this carbon atom to form a double bond between carbon atom and oxygen atom. So in the end we'll be getting something like 2 moles of HCHO plus HIO3. Okay, how is this forming? We're getting something like this for the first carbon atom, and for the second carbon atom again we'll be getting O negative here. So O negative will form a double bond with this carbon atom. Okay, in order to compensate for the positive charge which it would have got because of the cleavage of this bond. Hence we'll be getting positive charge here, negative charge here, positive negative again forms a bond between themselves, and we'll get something like this. So 2 moles of HCHO hence would be formed. So this is the mechanism of HIO4. So the short trick of calculating the final compounds is obviously clear to us, that just you have to cleave the bond between two carbon atoms by having OHOH attached on either side of the carbon atoms. So what happens when it reacts with HIO4 minus? We need 3 moles of HIO4. Why? Because obviously we have 3 carbon atoms or 4 carbon atoms and 3 bonds between those 4 carbon atoms. Hence we'll need the exact same number of moles of HIO4 as the number of bonds between the 4 carbon atoms. The number of bonds, CC bonds between 4 carbon atoms would be 3. Hence we will need 3 moles of HIO4. Okay, so now we'll get something like 2 OHOH on this carbon atom. It would be HCHO. Similarly, 2 OHOH on this carbon atom, it will be 2 moles of HCHO. And then at this carbon atom and this carbon atom we have 3 moles of HCHO, one coming from this side and another coming from this side. Similarly, for third carbon atom we'll have the replica of what is happening at the second carbon atom. So we'll have 2 moles of HCO2H formed. Okay, so this is the final product. What happens in this case? So bond cleavage here, here and here. Now what will happen here is we have OHOH here. So at this carbon atom we will have a position of 2OH. It would result in HCHO formation. Similarly for this carbon atom it will be the same, hence I am just writing 2 moles of HCHO. At this carbon atom what will be happening is we are already having C double bond O, and we will be having 2 OH attached here. Okay, so what will happen in this case is obviously CO2 gas would be evolved with the dehydration taking place here. Okay, and for this carbon atom what would be there? We have H, C, OH, and 2 more OH would be there, one from the upside and one from the bottom side, and we'll be having HCO2H here. So these 3 are the main compounds which are formed. Okay, what happens in this case? We have something like this. And finally we have CH2OH. Okay, what happens if we take 5 moles of HIO4? Why 5 moles? Because there are 6 carbon atoms. 6 carbon atoms will give me 5 bonds, hence 5 moles of CO2H. 1 2 3 4 5 and 6. Just cleave all the bonds in between. Okay, let's go step by step. What if when we cleave this bond, first carbon atom would be having CHOOH, it would be nothing but HCHO for the first carbon atom. For the second carbon atom, we would be having OHOH. Oh, I'm sorry, this is not HCHO, this is carboxylic acid. So this is first carbon atom would be having HCO2H. For the second carbon atom again will be having 2OH from the HIO4 cleavage, and 1 OH was already attached on the carbon atom, hence we'll be having 3 OH, and whenever 3 OH are attached on one carbon atom, it would form carboxylic acid, hence we'll be getting HCO2H for the second carbon atom as well. Okay, for the third carbon atom again the same structure, so HCO2H again. For the fourth carbon atom again the same structure, hence HCO2H again. For the fifth carbon atom again the same structure, 3 OH on one carbon atom after the cleavage forms a carboxylic acid group, and for the sixth carbon atom we would have a aldehyde group, hence total products would be 1 mole of HCHO and 5 moles of HCO2H. Okay, let's look at another example where we have something like this, and HOH here, HOH here, HOH here, and finally we have CH2OH. Okay, now how many moles of HIO4 will be required? 1 2 3 4 5 6 carbon atoms are there. 6 carbon atoms equals to 5 bonds equals to 5 moles of HIO4. So what would be the product formed? For the first carbon atom it would be nothing but HCHO. Okay, same for the last carbon atom, hence 2 moles of HCHO would be formed. Okay, for this carbon atom, OH on OH and C double bond O attached, it will give rise to CO2 evolution. Okay, this carbon atom is also solved. This is done, and this is done. Next, for all these intermediate carbon atoms, it would be having 3 moles of HCO2H. If we take the example of any carbon atom, let's take example of this carbon atom. On this, OH was already attached, and 2 OH will be coming from the bond cleavage due to HIO4, and 1 H was already attached to it. So 3 O's and 1 H on a carbon atom will give rise to HCO2H. Okay, so with this we come to an end of this lecture. In the next lecture we'll be taking up some more examples on oxidizing agents like HIO4 and KMNO4. Okay, so till then, good luck and goodbye.